as we get into adulthood, most of our neural maps in the brain, certainly our sensory maps and our cortex, our motor maps that allow us to move in particular ways, those have been established. You can still change them, but they've mostly been established throughout childhood and into our early 20s. And if we want to modify those circuits with neuroplasticity, there are a couple of key requirements. One, you need to be alert. You can't get neuroplasticity. That is, you can't trigger neuroplasticity unless you're alert. You also have to be focused. This is critical and differentiates adult plasticity in a major way from plasticity when we're young, where we can learn by passive exposure. Okay? When we're young, we can learn by passive exposure, or even better, by focused exposure. But when we are adults, we need alertness and we need focus. Just passively being exposed to, music or to a motor pattern is not going to allow us to change our nervous system. That's been shown over and over again. Fortunately, what also has been shown over and over again is that if we are alert and we're focused and we are determined, especially if we undertake what's called incremental learning, where we go after small bits of neuroplasticity repeatedly over time, we can get as much neuroplasticity as one observes in childhood. It just takes longer, and you have to do it so-called incrementally. There's a lot to say about that, but for sake of today's discussion about the vagus nerve, I just want to tell you that there's a particular pathway in the brain that involves the molecule acetylcholine. Acetylcholine is used to contract the muscles. It's released from motor neurons in the spinal cord onto muscles to contract the muscles. It's also used in the brain and elsewhere in the nervous system, and it does a lot of different things. It's actually involved in generating the rhythms of the heart. But acetylcholine released from a particular nucleus in the brain called nucleus basalis. The acetylcholine released from nucleus basalis is what we call permissive for plasticity. In other words, if you have acetylcholine released from nucleus basalis into the brain, plasticity is much more likely to occur. And in fact, acetylcholine released from nucleus basalis is sort of like a gate whereby if you release acetylcholine, the opportunity for neuroplasticity and learning is available for some period of time. So the question therefore becomes, how do you get acetylcholine released from nucleus basalis? There are these incredible experiments that have been done by Mike Merzenich and colleagues, showing that if you stimulate nucleus basalis to release acetylcholine and you expose an animal or a human to a particular sensory stimulus, the brain remaps very fast according to that experience. Just enormous amounts of plasticity that you wouldn't observe otherwise. There are also, fortunately, experiments showing that if you pharmacologically increase acetylcholine, that you can enhance the opportunity for neuroplasticity. You still need to do the learning. You still need to attempt to learn something. You still have to make it incremental, but the amount of plasticity is significantly increased when there's acetylcholine released from nucleus basalis. So, in the absence of deep brain stimulation using an electrode, which most of you fortunately will not experience because it requires drilling down through the skull and placing an electrode in basalis, and assuming that you're not taking anything to increase acetylcholine transmission to learn, although there are ways to do that. I've talked about that before, and I'll talk about that again in a future podcast. Some of those ways include supplementing with things like alpha-GPC, which is a precursor to acetylcholine. There are some other precursors to acetylcholine or things that stimulate the release of acetylcholine, such as huperzine and things like that, that will open the opportunity for enhanced plasticity for a few hours. And there is good old nicotine. I know the word nicotine brings to mind things like lung cancer because for many, many years, many people, and still now, smoked nicotine in the form of cigarettes or vaping, both of which I think are absolutely terrible, as is dipping and snuffing, because yes, they increase levels of nicotinic acetylcholine receptor activation, which is just fancy nerd speak for acetylcholine transmission in the brain is enhanced by nicotine, but those delivery mechanisms also, of course, can give you cancer in the case of smoking, dipping, or snuffing, and vaping, despite what you hear out there, is absolutely terrible for your health. I don't care what anybody says, the evidence is starting to really pile up that vaping is bad for you. Now, is oral form nicotine bad for you in the form of gum or in the form of a pouch, etc.? I just want to say a couple of things. One, it's extremely habit forming. Two, it increases blood pressure, and it's a vasoconstrictor. These drawbacks about nicotine are real and are critical to consider if you're going to use nicotine as a focusing agent or a so-called nootropic. I don't really like that word, but if you're using nicotine as a way to enhance cognition and enhance neuroplasticity, you should know what the potential drawbacks are, most notably the habit forming and addicting properties, which are very robust. Now, with that said, there are ways to non-pharmacologically stimulate the nucleus basalis acetylcholine pathway to enhance the window for plasticity. And the way to do that is, you guessed it, through the vagus nerve. Studies in healthy humans and humans who have had, for instance, stroke, as well as animal studies have shown that if you stimulate the vagus nerve electrically, you increase the level of alertness in the brain, and part of the mechanism by which you do that is the one I told you about a few minutes ago, the adrenals, vagus, locus coeruleus, but also there's a separate pathway from the NTS to nucleus basalis that stimulates the release of acetylcholine from nucleus basalis and opens up the opportunity for neuroplasticity. This, I should mention, is not a small effect. It is a rapid effect, and it's one that has allowed stroke patients, for instance, to improve their motor capabilities very quickly as compared to when the vagus nerve is not stimulated or when acetylcholine transmission is not enhanced pharmacologically. And fortunately now, there are studies starting to accumulate in animal models and some in humans. We need more, but there are some showing that if you enhance alertness by way of activating the vagus nerve through the mechanism that I told you before, which is good old-fashioned high-intensity exercise, that in the several hours following that exercise, there is an enhanced opportunity for neuroplasticity. Now, that enhanced opportunity for neuroplasticity comes by way of two different pathways. You already heard about the first one, which is the locus coeruleus release of norepinephrine. That's going to increase alertness, which is a prerequisite for focus. And it appears to be the case that the release of acetylcholine from nucleus basalis that's also triggered by this high-intensity exercise is what allows for that alertness to be converted into focus. And those two things together, alertness and focus, are the triggers for adult neuroplasticity. If you think about this, this is really exciting. For 25 years or more, we've known that plasticity is possible in the adult human. We knew you needed alertness and you needed focus. We also, by the way, know that you need to get great sleep that night and in subsequent nights in order to actually allow the plasticity to occur. Plasticity is a process. It's not just triggered when you go about trying to learn something. It actually takes place in sleep, as well as sleep-like states like non-sleep deep rest and meditation, but especially in deep sleep and rapid eye movement sleep. This is why you can attempt to learn something cognitively or behaviorally over and over and over. You can't get those scales on the piano right. You can't get the information dialed in from your class, a language class, or from engineering, or you're trying to figure out what this picture should be in your mind that you're going to paint, etc. You work at it, you work at it, you work at it, you sleep, and then one day you wake up and suddenly you have the skill. It's because the actual rewiring of those circuits that we call neuroplasticity occurs during sleep, but it's triggered in those moments of incremental learning and really struggling. And keep in mind, the struggle to learn something, that friction is part of the neuroplasticity process. And it's oh so clear now that alertness and focus are the prerequisites for plasticity, that alertness is coming in large part by way of the release of norepinephrine from locus coeruleus, that the focus is being augmented, and perhaps it's even originating entirely from the release of acetylcholine and nucleus basalis that acts as sort of a spotlight on a particular set of things that are happening while we're trying to learn. And then that triggers the plasticity process, which takes place during sleep. So that beautiful picture of self-directed adaptive plasticity in adulthood is allowed to happen because the vagus nerve, in part, is triggering NTS to say, hey, locus coeruleus, nucleus basalis, wake up, release norepinephrine, release acetylcholine. Now's the time to learn. So what this means is, if you're struggling to learn, if you want to continue to have robust neuroplasticity, if you happen to have some damage to motor pathways, or you're having trouble with focusing and brain fog, keep in mind, focus itself is served by a circuit that is subject to plasticity. You can actually get better at focusing by working on focus just the same way you would on any skill. And so if you're struggling with focus, I highly recommend finding a threshold of exercise that stimulates brain alertness, that triggers these pathways that are now starting to be clear that they occur from the literature in animals and humans. And yes, you might augment this with something like caffeine, which will further increase levels of norepinephrine. You might even use low-dose nicotine. I'm not necessarily recommending that, certainly not for young people. And you do need to be aware of the habit-forming, aka addictive properties of nicotine. You definitely don't want to consume it in any form that's going to cause you to increase your risk of cancer or popcorn lung from vaping. You could use pharmacology. You could use alpha GPC. You could use huperzine in combination with exercise. However, I strongly, strongly recommend that anyone who's interested in lifelong learning, think about organizing your bouts of learning, especially cognitive learning, to come in the 2 to 3 hours, maybe even 4 hours, but certainly in the 1 to 2 hours after you do some sort of exercise that doesn't leave you exhausted, but leaves you with elevated levels of energy in your body. So you don't want to take this physical exercise that I'm talking about to exhaustion, because that's going to leave you depleted. That's going to cause a, uptick in parasympathetic activity. Any of you that have done a hard leg workout and then, 2-3 hours later, you're just like, it's very clear brain oxygen levels are down, parasympathetic activity is up. You are tired because you exhausted all that energy in exercise. But if you can use exercise as a trigger to release adrenaline and stimulate these pathways within the brain that arrive via the signaling from the vagus, you do indeed open up the opportunity for enhanced neuroplasticity at any age.